think there's some people in the other class that weren't here today, so then they can see all the notes. Ooh, here's your first two definitions. Pause it. All right, here's the next definition. Pause it. And here we are in prime factorization. So we're just taking a number and we're breaking it up. 24, 4 times 6. But that, if there are numbers here that you can break up even further, because 4 is 2 times 2, and 6 is 3 times 2, that breaks it up further. And then we have the prime factorization in the end. So 126 is what times what? 63 times 2. Good. And 63 is? 7 times 9. Are we done, or are there numbers we could break up further? 9 is 3 times 3. So the prime factorization is there. You could write it as, usually we start with the lowest number and write things as powers if there's more than one of them. So we'd have 2 times 3 squared times 7. This is one technique for doing it, just writing it out straight like this. Another technique, as we'll see in this example, is something called a factor tree. And then I'll show you another technique that just different ways of doing the same thing. And you can decide which one you like the best. This is what a factor tree looks like. And you may have done this in grade 9. 144 is what times what? 12 times 12. Then you look at 12 times 12 and you say, can I break that up further? Okay. Somebody says 6 times 2. Somebody else says 4 times 3. It doesn't matter which one you choose. The factor tree will work out in the end. And then finally, you look at any of these. Can they be broken up? Yes. 3 and 2 and 4 is 2 and 2. The one thing that makes me not a huge fan of the factor tree, besides the fact that it takes up a lot of room, is sometimes when you're writing out the prime factorization, 144 is equal to, sometimes people miss some of the numbers because you have to go to the end of the branches. And if you just go to the bottom, can you see that I missed this one and this one? So that's part of the reason that factor tree, I sometimes don't like it. It's not my favorite, is because people tend to miss some of those numbers. But if you're careful, how many 2's do we have? 1, 2, 3, 4 of them. 2 to the 4 times 3 squared. So that's one technique. That's called a factor tree. Over the years, I've seen different techniques. One that I really like is with just drawing 144 there, and then starting with your smallest prime numbers, which is 2. Can you divide 144 by 2? Yeah. Yes. So put a 2 on this side and divide it, and you get 72. Can you divide that by 2? Yeah. Yes. So you put a 2 here and divide it, you'd get 36. Can you divide that by 2? Yeah. 2 there, you would get 18. Can you divide that by 2? And then you get 9. Can you divide that by 2? No. So then our next prime number is 3. Can you divide it by 3? Yes. Can you divide 3 by 3? Yeah. Yes. And you go until you get down to 1. Once you get down to 1, do you see this lines up nicely to give us the same answer, 4 2's and 3 squared. I like that because it takes up less room, is a little bit more organized. But you can choose whichever technique that you like. The next one for you to try is 2,646. That's not a nice number? 2,648 is not nicer, if that's a word. If this one's not nice, 2,000, add 2 more and it makes a not nicer number. This one actually turns out not bad. Like 8? Wouldn't that be? Here we go. So 26, 46. Can you divide it by 2? Yes. 13, 23. Can you divide that by 2? No. You can divide it by 3. Does anyone know the trick for dividing by 3? Do the thing. You add all the numbers up 1 plus 3 is 4, plus 2 is 6, plus 3 is 9, and since 9 can be divided by 3, this number can be divided by 3. How many people have never seen that trick before? All right, it's a cool one. So now if I divide this by 3, I'm going to get 441. Whoops, that's where the 3 goes. Divided by 3, I get 441. Add those digits up, they add up to 9. So it can be still divided by 3, and we get 147. Add those up, they divide by 3, so it can divide by 3 again, and you get 49. 7, 7, 7, 1. So now we are done. We know that 2,646 is equal to 2 times 3 cubed times 7 squared. Oh, and Yasmin, you wanted to see the one you were working on, which was 8. You almost done? Get 2. You did the other one? Well, just if you're checking. And you can watch that later. That'll be on video. You're welcome.